Okay, so the mean value theorem. I give you a function that's continuous on the closed interval AB. I give you a function that is also differentiable on the open interval AB. As a result, take the slope of the line between the two endpoints, the dashed black line. The slope of the black dashed line, the slope of the line between the two endpoints is going to be equal to the tangent slope at some point. So, as an example, let's demonstrate the mean value theorem for the function f of x equals x squared on the interval 0, 2. Now, first key thing, if you're ever going to demonstrate the mean value theorem, we showed you must be continuous and you must be differentiable. So the first thing to notice here is that f of x equals x squared is continuous. Why is it continuous? It's a polynomial, and any polynomial function is continuous. Also, second key point, f of x, and I should be very clear here, this function is continuous on the interval closed 0, 2. God, I would have lost a point on the test. Because it's a polynomial, it's continuous, in fact, along all of the x-axis, but in particular, it's closed on our continuous on our closed interval, 0 to 2. F of x equals x squared is also differentiable on the open interval, 0, 2. And why? Because it's a polynomial. In fact, a polynomial is going to be differentiable everywhere because you can take its derivative. In particular, its derivative is 2x. So now, we've got the criteria met to guarantee the mean value theorem. So we've established that we are continuous on the closed interval, we've established that we are differentiable on the open interval, and now we can proceed with solving the problem. So now, we are going to compute f of 2 minus f of 0 over 2 minus 0, and set that equal to f prime of c. What we are doing is taking the content of the mean value theorem, the slope of the line through the two endpoints, that is between the points x equals 0, x equals 2, that's f of 2 minus f of 0 over 2 minus 0, change in y over change in x. This is going to be equal to f prime of c for something. Now, you can see in this statement, that is the statement that follows from the mean value theorem, there's only one letter, and the letter is c. So the goal now at this point is to find our c. So f of 2, plug 2 into your function. That's going to give you 4. Plug 0 into your function. That's going to give you 0, right? Because 2 squared is 4, 0 squared is 0. Downstairs you have 2 minus 0. Long story short is what is on the left-hand side is 4 over 2. That is just 2. What about on the right-hand side? The right-hand side is f prime of c. Well, you know what f prime of x is. F prime of x is 2x. So f prime of c is 2c. The left-hand side is the slope of the line between the 2 points. The right-hand side is the derivative with c plugged in. And what do we have? We have 2c equal to 2. You can solve that out. c equals 1. And what is this saying? Because let me take a moment to address what this is saying so that we can see with our eyes literally what is happening. I mean, we can see from the act of solving the problem that since we have a continuous and a differentiable function, we can apply the mean value theorem because that was the condition, or those were the conditions upon which the mean value theorem could be applied. But what is our function here? Our function is a good old-fashioned parabola. F of x equals x squared. And we're looking at the parabola between x equals 0 and x equals 2, which is this piece right here. And what the mean value theorem has told us is that when you look at the slope of the line through the endpoints, this has a slope of 2. And you know this because, well, we ran the numbers on this. Here's over 2 up 4. Here's over 0 up 0. Change in y, 4. Change in x, 2. And we got a slope of our average line between the two endpoints of 2. But now, what did the c equal 1 tell you? The c equal 1 tells you where the derivative had the same slope. And guess what? Go here to x equals 1, take a look at that point. What's the slope at that point? The slope at that point is the same slope as the average slope. The long story short is the mean value theorem works. And guess what? Anytime you've got a continuous function on the closed interval and a differentiable function on the open interval, you can apply the mean value theorem. You'll have all numbers on the left, you'll have the derivative with c plugged in on the right, and you just play math to figure out what the c is, and once you've got it, you've got a point where the slope of the tangent line equals the slope of the average rate of change between the two endpoints. And well, I guess what counties in Texas are collecting a whole hell of a lot of money from tickets off of this very principle.